Hi everyone, we are going to take some notes together here on chapter 10, which is all about probability. Now, our probability chapter is going to be a bit different than all the other maths we're used to. No more function families. Let's just start with an intro to section 10.1. Okay. And let's define what a probability experiment is. A probability experiment. So just like in class, we're writing along with me, we're taking some notes. A probability experiment is an action or trial that has varying results or outcomes, we might think. Okay, and for example, some really basic ones. Let's think about a coin flip, maybe a dice roll, a couple dice are rolled, or even something like the lottery. All these involve probability. Okay. An important term for us in this first section is the sample space. The sample space is the set of all possible outcomes. Okay, the sample space is the set of all possible outcomes. We'll look at some experiments and then their sample space. So let's take a moment and make a table with two columns, not very big, but on the left side, the experiment, on the right hand side, the sample space. And really basic one to start, a coin flip. What's the sample space for a coin flip? What are all the possible outcomes? Well, just heads or tails. So the sample space has two possible outcomes. Heads or tails. Okay. What about a die roll? Okay, die being one, we roll one die. How many possible outcomes are there? Well, die has 6 sides, 1 through 6, so sample space has 6 possible outcomes. We go 1, 2, 3, 4, 5, 6. Those are all the possible outcomes in that experiment. Okay. You can always pause our video and write these notes and click play when you're ready to keep going. Let's look next at let's get a definition for probability. So the probability of an event is a measure of the likelihood or chance, we might say, that the event will occur. Okay. We measure probability as a value. The probability is a number value from, I'm sorry, you can't yell at me and tell me to scoot it up, so I'll pay attention. I will get better at this. From 0 to 1, where if our probability was 0, that would be impossible. This thing is never going to happen. If it was 1, it'd be certain. It will definitely happen. So let's think about this more. Let's make sort of a number line that spans from a probability of 0 to a probability of 1, where 0, it's impossible. There's 0% chance that this will happen. or all the way up to 1 where it's certain. We know this will happen. It's 100% likely. Okay. Well, in the middle of 0 and 1, we have 1/2. 1/2, we have a 50% chance probability, and this is equally likely and unlikely. Okay. If we had a 1 out of 4 chance, that would not be very likely. That'd be unlikely. Although a 25% chance maybe in the lottery would be pretty good. But something that is likely would be maybe 3 out of 4, and that being a 75% chance. So this is just a baseline for us to think about probability as a number value between 0 and 1. Okay. Now, we have one more little sheet to go through, and this one, let's title, or not title, let's just start with a big, important definition for theoretical probability. Probability. Okay, and actually this is more of an equation. Theoretical probability is defined by the number of favorable outcomes divided by total number of outcomes. Okay, I'm actually I want us to put a box around this. This is an important, it's not a very complicated equation, but important for us in this chapter. And one more note before we finish with an example. The probability of event A, some event, we're calling it A, is written as P of A. Now, this is just a notation thing. If the probability for A to occur, we would write as P of A. Okay. Let's look at an example. Let's take the next few minutes to finish with an example. So the example here is that a student taking a quiz randomly guesses the answers to 3 true or false questions. Okay, that's the situation here. Our work, we want to determine what is the probability the student guesses, what is the probability the student guesses exactly 2 correct questions? Okay, we're wondering that. Now, probability is kind of a different kind of math, not a lot of solving. We kind of got to map this out. So let's think about what the sample space could be. Okay, so let's make a table with the different outcomes. Okay, and let's think about the number of questions correct. Okay, there are 3 questions total, 3 questions. So there could be 0 correct. That student could get 1 correct, 2, or all 3 correct. So these are the different cases: 0 correct, 1 correct, 2, or 3. Okay. Now, there's many different outcomes that could allow this to happen. Let's consider 0 correct. Okay. If there was 0 correct, they would get the first question incorrect, second, incorrect, and third question, incorrect. Okay, I for incorrect. If this person got one correct, maybe they got the first question wrong, incorrect, the second incorrect, but maybe they got the third and final question correct. Okay. There could be another case where they first question incorrect, second correct, third incorrect. All right. Finally, they could have gotten the first question correct, the second and the third incorrect. All right. Now let's consider them getting two correct. Maybe they got the first incorrect, but the second and the third correct. That could happen. Maybe they got the first correct, the second incorrect, and the third correct. And then finally, maybe they got the first two questions correct, but the third one was incorrect. All right. The last outcome, there's only one outcome in which the student got all three correct. There's only one case you could get all first correct, second correct, third correct, since there's only three questions. Okay. What's the sample space for this? Sort of a side question. What's the sample space here? Let's think about this. Well, there's three questions, right? And what are the different outcomes for each question? Well, the first question, they could either get it true or false. The second question, either true or false. The third question, true or false. So if we multiply all of these events together here, first question, second, and third, we have 8 outcomes. Okay, and that also matches what our table says, 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay, so when we're going to move towards what is the probability of the student guesses exactly 2 correct. Let's write that out. We got probability of exactly, remember our notation here, P of A, so probability exactly 2 correct. That equals the number of favorable outcomes. Go back to your equation, number of favorable outcomes. Well, we're talking about getting 2 correct, so we look at having 2 correct. How many cases were there? 1, 2, 3, okay? So actually, I'm going to write that whole equation again. Number of favorable outcomes, we recognize as 3, divided by number of total outcomes. We just figured out that was 8. So we have 3. There were 3 cases of getting 2 correct, or right here. And then there were 8 total. So the probability here is 3 out of 8. There's a 3 out of 8 chance this student could have guessed exactly 2 correct. And we might write that as 3 over 8, or the percentage, which is 37.5%. Okay. All right. Stay tuned for some more notes on Wednesday. Okay, I will get better at these videos.